Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
And welcome grade 9 learners. Welcome to today's Natural Sciences live lesson. My name is Sianda Majala and this lesson is brought to you by the Gauteng Department of Education. Right, we've been talking about acids and bases, right? So today I want us to mainly focus on the general reaction of an acid with a metal carbonate. Now look at this, right? A metal carbonate is also labeled as a base. So we're still emphasizing the issue of acids and bases. So this is where we're talking about the metal carbonates acting as bases against acids. So now I hope you are ready for more, right? And this topic is also found under the knowledge area, matter and materials for our term 2. Now let's look at the lesson objectives. So now, by the end of this lesson, you should recap on what a metal is. Still remember we talked about metals, right? Those that are found on the periodic table on the left-hand side. So we're going to recap on what they are because we're going to talk about metal carbonates, right? Also, this lesson, you should revise acids and their properties. So we're going to revisit acids and their properties as well, so that we come along with this lesson very well, right? Also, you should be able to revise balancing neutralization reactions, right? So we're going to revisit neutralization reactions as well, where we're talking about acids and bases counteracting each other. So now, we're also going to be able to know the elements that make up carbonates and metal carbonates. Also, you need to know the general reaction between an acid and a metal carbonate, which is the main meal for today. And lastly, we are going to test whether the reaction between a carbonate and an acid releases carbon dioxide gas. So we're going to have an experiment as well, right? I hope we are ready. And all this is found where? In the source of CAPS document, page 68. Now let's move on. Let's look at the pre-knowledge now. Pre-knowledge is what we have done in terms of topics in the previous grades and also the same grade prior to this lesson, right? So in grade 8, we have done atoms, which are our building blocks of matter. You still remember that? We also have done in grade 8 chemical reactions. We also have done in grade 9 compounds, right? Which are two or more different elements chemically bonded in a fixed ratio, right? We also have done acids and bases. We also have done neutralization and pH, which I said that we are going to revisit again so that we come along with this topic very well, right? We also have done the reactions of acids with metal oxides. So now I hope you are ready and keep in mind these topics for our pre-knowledge because we need that information so that you can be able to understand today's topic, right? So now, let's look at this baseline activity. I'm going to give you 5 minutes for you to complete this baseline activity, but firstly, let's go to the questions. Number 1, write down the formulae for Roman figure number 1, 2 metal hydroxides derived from group 1 elements of the periodic table. Roman figure 2, 2 metal hydroxides derived from group 2 elements of the periodic table. Number 2, consider the following reaction. Na plus H2O forming NaOH plus H2, right? It is a balanced equation of it, right? 2 sodiums plus 2 water molecules forming 2 sodium hydroxides plus 2 hydrogen molecules, right? Name the compounds in this equation. Then 3, name the products formed during the neutralization reaction. For 5 minutes. We'll meet again after 5 minutes. Welcome back, grade 9 learners. Now, I hope you have enjoyed our baseline activity, right? If so, it means we're going to work along very well going forward, right? But remember to send your answers or questions to 079-578-2908. Don't forget that, right? So now, let's look at the solutions for our baseline activity. Number 1, it said write down the formulae for Roman figure 1, 2 metal hydroxides derived from group 1 elements of the periodic table, right? So what is the answer there? The answer is, you can find lithium hydroxide, right? These are the key metals that I'm talking about, right? But now, the metal hydroxide formed from the elements that are found in group 1 is lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and so on, right? Don't forget to mark any 2 that we have written there. Number 2, 2 metal hydroxides derived from group 2 of the elements of the periodic table, right? It is beryllium hydroxide, magnesium hydroxide, calcium hydroxide, and whatever 2 that you have written from there, right? So now, number 2, consider the following reaction. Is sodium plus water forming sodium hydroxide plus hydrogen, right? So now, name the compounds in this equation. The compounds are water and sodium hydroxide. Mark your work. Then number 3, the products formed during the neutralization reaction. And the products are salt and water. So now I want us to take a minute and copy down the corrections. Welcome back, grade 9s. Now let's carry on with our work. Now, terminology. Terminology is so important so that you are able to understand the concepts and the topic itself, right? The first one there, we have neutralization. What it means to neutralize something, or what is this neutralization? Neutralization is the chemical reaction in which an acid and a base react to produce a salt and water. So now, look at this. We have talked about reactants and products, right? Which ones are our reactants in this case? When you neutralize solutions, you have acid and base being the reactants, right? And your products is the salt and water. So now bear in mind all the time when you're talking of neutralization in terms of chemistry, it is the chemical reaction in which an acid and a base react to produce a salt and water. Now the second one there, we have metal carbonate. What is this metal carbonate? A metal carbonate is a compound that contains a metal, carbon, and oxygen. Are we together? Still remember your periodic table. Where do you find metals? Where is carbon? And where is oxygen, right? So it is a compound that contains a metal, carbon, and oxygen all together at the same time, right? Now, acids. Acids, we said that it is a substance with a pH between 0 and 7, or it is an acidic substance that has a pH value of between 0 and 7. Then a base is a substance with a pH between 7 going up to 14, or between 7 and 14, right? Now let's move on. Now remember, I said that you're going to revisit acids, right? So now the first question there, what is an acid? We just defined an acid now. We said it is a substance that has a pH value of between 0 and 7, right? So now we can therefore say an acid is a substance with a pH value of between 0 and 7. Not only that, an acid is a solution that has an excess of hydrogen ions, right? The more the hydrogen ions, the more the acidic the solution is, right? It has excess of hydrogen ions and it comes from the Latin word acids, that means sharp or sour. Now, talking about sharp or sour, remember when we talked about the properties of acids, we said acids are sour in taste, right? So we're going to revisit that as well. So now, we said that the more the hydrogen atoms in a chemical formula, the more the acidic the solution is. And acids, we also find what? The element hydrogen in front of its chemical formula. Right. Properties of acids. What characteristics these acids have here? First of all, they have a sour taste. Still remember that. They have a sour taste. Secondly, they feel rough, right? They feel rough. Thirdly, they turn blue litmus paper red. So you still remember when we were doing the testing of household substances for acidity or alkalinity, right? When certain substances are acidic, it turns the blue litmus paper into a red color, right? Also, they have what? They have a pH of lower than 7. Not only that, they have excess of hydrogen atoms, right? And it usually has what? Hydrogen in front of its chemical formula. Also, they can do what? They can neutralize a base, meaning they can make a base to become weak, right? And lastly, they are soluble in water. Now, examples of these acids that we're talking about. The first one there, hydrochloric acid, which is the acid that we find in our stomachs, right? Now look at this. It has what? Hydrogen in front of the chemical formula. The second one there, sulfuric acid, right? Which is symbolized as H2SO4, right? The following one is nitric acid, HNO3, and vinegar. So you still remember our test for acid and alkalinity. When we tested for vinegar, we found out that vinegar is acidic, right? So vinegar is also an example of acids. Another one there is citric acid, which is found in citrus fruits. So now I want you to take a look at this sign here, right? This sign serves a purpose of showing that substances that have this sign are acidic, right? It can be this one as well, to prove that or to show that a substance has what? An acid in it, or it is acidic. So look out for those substances at your homes, right? That have these signs to show that there is an acid or the substance is acidic. Now, we said that acids and bases can neutralize each other, right? And we call that one a neutralization reaction. So I want us to revisit that before we carry on with our lesson. So we said that if you mix an acid and a base, a chemical reaction takes place. What is that chemical reaction? And we have mentioned that in our terminology, right? What is that chemical reaction that takes place when you mix an acid and a base? We call that one a neutralization reaction. So in a neutralization reaction, you have the acid and the base counteracting each other, overcoming each other, or cancelling each other, right? Making each other weak. So now, we said that the acid and the base counteract each other. And here is the general formula for the reaction of acids and bases, right? You find acid plus base forming a salt and water, right? Which ones are your reactants here? The reactants are the acid and the base. And the products are the salt and the water. So now I want us to look at this example in the form of chemical equation. Hydrochloric acid plus sodium hydroxide, forming sodium chloride plus H2O. Now, if you take note, sodium chloride is a type of salt, right? So it means what? The type of salt that is going to be formed at the end of the reaction, it depends on the type of acid and base that take part in the reaction to bring about that type of salt, right? As you see the general equation here, it says you mix an acid plus a base to form a salt and water. So now, which one is the salt here in this reaction? Which one is the salt? The salt is sodium chloride, right? This one. This is our salt. It is the sodium chloride. Now look at this carefully. It comes from this. The chlorine comes from the chlorine which was in the reactants in the hydrochloric acid, right? And the sodium comes from the base which was in the reactants, and they formed what? NaCl, which is sodium chloride. So there's some rearrangement of atoms. That's what I want you to notice, right? There's no deletion or addition of any atom, but there's simply a rearrangement of atoms. Now, moving on. Metals. Let's revisit metals again to understand where we are going with this topic, right? What is a metal, first of all? That's the question I'm asking you now. What is a metal? Your answer should be along this one, right? A metal is an element that is malleable, ductile, and conducts electricity, right? For example, you have iron, copper, and zinc in the following reactions as well, or the following symbols. Iron as Fe, copper as Cu, and zinc as Zn. And here are some pictures to remind you of the types of metals I'm talking about here. Here is copper, here is iron, and here is zinc, right? So now, I want you to keep in mind that a metal is an element that can change shape. It is malleable, it is ductile, meaning it can be stretched into thin wires, and it can conduct electricity, right? And keep in mind these examples, the iron, copper, and zinc. Now, properties of metals. What characteristics does these metals have, right? First of all, they are sonorous. What does it mean when we say metals are sonorous? It means that they can give off sound, right? Like this bell that I put here, right? It can give off sound. When you have these two metals banging each other, they give off what? Sound. So we say metals are sonorous. Not only that, metals are ductile. So meaning they can be stretched into thin wires, like this copper metal that we have here, right? It can be stretched into thin wires. Also, metals are malleable. They can be able to change shape, right? They can be able to change their form, right? As you can see here, there's a person bending this type of metal to change its shape. Also, metals are shiny in appearance, right? Now look at this shiny appearance of these metals. Metals are shiny. Not only that, metals are having a high tensile strength, meaning they can withhold objects of high mass. They are strong, like these chains pulling each other apart, right? They have a strong force. They can withhold high strength. Now, carbonates. Now we're getting somewhere, right? Remember, we're talking about the reaction of acids with metal carbonates. We have touched on acids, we have touched on metals. Now we're touching on what? Carbonates, right? So what are these carbonates now? If I may ask, what is a carbonate? Still remember our definition. We said a carbonate is a compound consisting of a carbon atom and 3 oxygen atoms. In what manner? In this manner, right? As you can see, carbonates, 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 right? They have what? 1 carbon atom and 3 oxygen atoms. So when you see this, just know that it is a common group of compounds which is called carbonates, right? CO3. Now, here is a model form of it. Let's analyze this. If you look carefully, the black one here How many black ones do you find? You find 1. So it means what? It is 1 carbon. And how many red ones do we find? It is 1, 2, 3. That is your 3 oxygens, right? All forming what? A carbonate molecule, which is CO3. Now, let's talk about metal carbonates. What are metal carbonates, right? I told you now about carbonates. We said that they have 1 carbon atom and 3 oxygen atoms. So now, what are these metal carbonates? A metal carbonate also is a compound that consists of 1 carbon atom, 3 oxygen atoms, and a metal as well, right? In this format as well, metal carbonate, metal carbonate, metal carbonate, metal carbonate, right? As you can see here, MCO3, MCO3, right? Representing what? A metal carbonate. Now let's look at the model form of it as well. We have a metal here with a carbonate molecule forming what? A metal carbonate, right? Forming a metal carbonate, which is MCO3. So now that is the general metal carbonate. So we're going to look at more examples of metal carbonates. Right. Now, examples of metal carbonates. First of all, we said a metal carbonate is a compound that contains a metal, carbon, and oxygen, right? So now, for example, calcium carbonate. Why am I saying calcium? So now, if you refer back to your periodic table, you find calcium under metals, right? So calcium is an example of a metal. In this case, it is a metal which has bonded together with a carbonate molecule to form this calcium carbonate with a symbol of CaCO3, right? So now, calcium carbonate is commonly called limestone, and it is the main ingredient for eggshells, blackboard chalk, and bones, right? So now another example is sodium carbonate. Also, when you refer back to your periodic table, you can find sodium along what? Along the metals. So sodium is an example of a metal as well, which has bonded with a carbonate molecule to form a metal carbonate, which is sodium carbonate with the symbol Na2CO3. Right. So now metal carbonates are bases. So what does it mean about metal carbonates? It means that metal carbonates can neutralize acids, right? They can counteract acids. When they react with acids, they're going to form what? Salt and water. But in this case, they can also form what? Carbon dioxide. That is what we're going to look at more on the following slides. Right. Here's an example of limestone or chalk or calcium carbonate that you are familiar with, right? The chalk that we use to write on our blackboards. Right. We say that metal carbonate can neutralize what? Can neutralize acids. So when any acid reacts with metal carbonates, the products formed are a salt, carbon dioxide, and water. So in this case, you form 3 products, which is salt, carbon dioxide, and water, right? We're going to look at the general reactions as well. But remember that the type of salt that is formed, it depends on the type of acid and the type of metal carbonate in the reaction, right? To bring about the product which is salt, right? So the type of salt formed depends on the specific acid and metal carbonate used in that reaction, right? So now moving on. Here's the general reaction of the acids with metal carbonate. It is an acid plus a metal carbonate forming a salt plus carbon dioxide plus water. So we form 3 products from that reaction, right? The products are salt, carbon dioxide plus water, right? Also, let's look at more examples. Let's look at the reaction between hydrochloric acid and calcium carbonate. And the equations for that are, starting off with the word equation, it is hydrochloric acid plus calcium carbonate forming calcium chloride plus carbon dioxide plus water. Now look at this type of salt, right? There has been some rearrangement of atoms, right? You find that the chlorine, that is the chloride on the salt, comes from the hydrochloric acid, and the calcium comes from the base in this reaction, which is calcium carbonate. Are we together? To emphasize more on the issue, to say that the type of salt formed comes from the type of acid and type of metal carbonate in the reaction, right? So now, let's look at the unbalanced equation of it. It's HCl plus CaCO3 forming CaCl2 plus CO2 plus H2O, right? So if you look at this, the equation is not balanced, right? Because the number of atoms on either side is not the same, right? So now, here is a balanced equation of it. Look at this. By simply adding this coefficient 2 here, by simply adding this coefficient 2, it balances the whole equation. Now let's count together. For the reaction side, 2 multiplied by 1 hydrogen, that's 2 hydrogens, right? Let's look at the products. We find 2 hydrogens as well. 2 multiplied by 1 chlorine. How many chlorines do we have now? 2, right? Let's look at the product side. We have Cl2, we have 2 chlorines. At the reaction side as well, calcium is 1. Calcium is 1 on the product. Carbon is 1 on the reaction side, and carbon is 1 on the product side. We have 3 oxygens, and we have 2 plus this one, we have 3 oxygens. So the whole equation is balanced. Now, let's look at this activity and try to test ourselves using this activity, right? So now, let me read through the scenario first. An antacid is any chemical that is used to treat acid indigestion. The antacid neutralizes the stomach acid, which is diluted hydrochloric acid. Calcium carbonate is a common ingredient of antacids. So number 1, explain what an antacid is. Number 2, explain why it is common to PEP after taking antacids. Number 3, complete the following equation, which is sodium carbonate plus hydrochloric acid forming Number 4, write down a complete balanced equation for the above reaction. Now, let's take a good 5 minutes to finish off this work, then we'll meet again after that. Welcome back, grade 9s. Now, I hope you were able to answer these questions, right? Now, let's look at the solutions. Firstly, let's just go through the questions again, right? Explain what an antacid is. Explain why it is common to burp after taking antacids. Complete the following equation. Sodium carbonate plus hydrochloric acid, they form Then number 4, write down a complete balanced equation for the above reaction, right? So now, let's look at the solutions. Number 1. Antacids are medicines that counteract or neutralize the acid in your stomach to relieve indigestion and heartburn, right? Don't forget to mark your work. Then number 2, the reaction of an antacid with hydrochloric acid in the stomach leads to the formation of carbon dioxide, CO2, and as a result, this can cause burping. Right, number 3. Here's the reaction. Sodium carbonate plus hydrochloric acid, they form sodium chloride plus carbon dioxide plus water. And lastly, number 4, the balanced equation, right? Na2CO3 plus 2HCl forming 2NaCl plus CO2 plus H2O. Now, let's take 1 minute just to copy the corrections and we'll meet again after. Welcome back, grade 9s. Now, let's carry on with some more examples before we continue with our lesson, right? Now, let's look at more examples. The first one there, showing the weight equation, it is magnesium carbonate plus sulfuric acid forming magnesium sulfate plus water plus carbon dioxide, right? In the following formula, MgCO3 plus H2SO4, they form MgSO4 plus H2O plus CO2. And here is our type of salt that is formed, which is magnesium sulfate. Now, second example, starting off with its weight equation as well, it is sodium carbonate plus nitric acid forming sodium nitrate plus water plus carbon dioxide, right? In the following formula, Na2CO3 plus 2HNO3 forming 2NaNO3 plus H2O plus CO2, right? And here is the type of salt that is formed again, which is sodium nitrate. Right. Now, we're going to have a practical investigation, right? Who can guess what we are going to do today? Who can guess what is the practical going to be about? Let me just give you 5 minutes to take a wild guess, right? We'll meet again after 5 minutes. We're still preparing for going to the lab. Welcome back, grade 9 learners. Now, who has guessed what we are going to do for today, right? Now, let's look at the aim for our experiment for today. The aim is to test whether the reaction between a carbonate and acid release what? Carbon dioxide gas. That's what we are going to do for today. Remember our lesson objectives. We're going to test whether a reaction between an acid and a carbonate, whether they release carbon dioxide or not, right? Our hypothesis. Our hypothesis is that the reaction between an acid and a carbonate does release what? Carbon dioxide gas. Now, let's look at the apparatus that we're going to need then, right? We're going to need bicarbonate of soda, vinegar, lime water, teaspoon or spatula, 2 beakers, 2 test tubes, a stopper, and a delivery tube, right? That's what we are going to need for our experiment, right? So now let's just take a minute to copy down the apparatus. Then after that, we get straight away to our experiment. Right, welcome back, grade 9s. Here we are with our apparatus. Now we're going to do the experiment, right? Step 1 of our experiment, we need to pour 1/4 of a teaspoon of bicarbonate of soda into one of the beakers, right? Or one of the test tubes. Secondly, we need to fill the other test tube with lime water, right? We're going to fill the other test tube with lime water. Thirdly, we're going to add hydrochloric acid to the test tube that already has what? That already has bicarbonate of soda. Then immediately close that test tube with a stopper and put the delivery pipe into the other test tube with lime water and see what happens, right? So now, let's carry on with our experiment. Right. Let's pour the bicarbonate of soda into a test tube. Right, here is our bicarbonate of soda. Right, the other test tube, we said we're going to fill it with what? With lime water. So we need a beaker to measure our lime water. Here we are, right? Now, I want us to pour some acid, which is vinegar, into the test tube that already has bicarbonate of soda, right? But we're going to use a beaker to measure our acid as well. Right. Now, remember, we need to close the test tube immediately after pouring, right? So I'm picking up my stopper and the delivery tube, right? So now, let's observe what happens. First of all, let's just make some space here. Right, look at that reaction, right? Now observe what happens to the lime water. Hmm. Right. Look at what happened to this lime water. Look at the color change, right? So now that's all for our experiment. Let's just take a minute to clear this up and we go back to our lesson. Thank you. Welcome back, grade 9s. Now I hope you have enjoyed our short experiment, right? Did you see the color change? Did you see the reaction between an acid and a metal carbonate? Right, now let's look at the observations. In terms of observations, you need to write down what does this experiment tell you about the reaction between a carbonate and an acid. Secondly, you conclude, right? You write up a conclusion. So I'm going to give you 2 minutes to fill up the observations. Welcome back, grade 9s. Now I hope you were able to write down the observations, right? Observation number 1, you needed to tell us that what does this experiment tell you about the reaction between a carbonate and an acid? Your answer should be along these lines, right? It shows that during the reactions of carbonates with acids, a gas in a form of bubbles forms, right? And you did see that, right? When the acid and the bicarbonate of soda were bubbling up, right? And to test that the type of gas formed is carbon dioxide, lime water is used. So let's write down the conclusion. The conclusion is that the clear lime water turns milky white to indicate the presence of carbon dioxide. So you still remember even in our experiment in grade 8, right? When we blew what? Air into the test tube with lime water, it became milky white to prove that the presence of, or there is a presence of carbon dioxide. Right. Now let's summarize what we have learned today. Today we are mainly talking about the reactions of acids with metal carbonates, right? So we said, what is a carbonate? We said a carbonate is a compound that contains one carbon atom and 3 oxygens. You still remember that, right? And we said, what is a metal carbonate? We said a metal carbonate is a compound that consists of one carbon atom, 3 oxygen atoms, and a metal as well, right? So now, we also said that the metal carbonates are compounds that contain a metal, carbon, and oxygen, right? And the example is calcium carbonate. We took calcium because calcium is an example of a metal, right? So as an example of a metal carbonate, we have calcium carbonate, that is symbolized as CaCO3. Also, we said that calcium carbonate is commonly called limestone and it is the main ingredient for eggshells, blackboard chalk, and bones, right? And we said that metal carbonates react as bases. Also, we said that when any acid reacts with metal carbonates, the products that are formed is going to be a salt, carbon dioxide, and water, right? And the type of salt also depends on the type of acid and the type of metal carbonate in the reaction. And we gave you a general reaction of acids with metal carbonates as acid plus metal carbonate forming salt plus carbon dioxide plus water. So now let's meet again next time when we are talking about the reactions of acids with metals, right? Come prepared as well. From me to you, keep on sanitizing, keep on wearing your facial mask, keep on also respecting others. Thank you and goodbye.